what I'm saying is that these cycles are not that, you know, if you look at it right there, it's not parallel, it's all over the place. And, yes, there's higher and lower areas, but I'm not totally sure we're out of the minimum yet. We've been trying it. We still, what I'm saying is we had several days where there was no sunspots like that.
Yeah.
It's sort of weird, because you think at this point we shouldn't be doing that.
Well, the scientists at NASA and the scientists determine the position in the cycle. The official way is by the polarity of the sunspots they see. And the polarity has changed over from what it was in sunspot cycle 23 to solar cycle 24 now. So they believe we are on the upswing. We may still be close to minimum, we may be close to maximum. Nobody knows. And that's the cool thing about the sun is that, you know, these brilliant people in this room can get together and talk all they want, but nobody really knows. Okay, you can generalize it, and you know, based on what I've seen, it's much, much more active now than it was, both visually and as far as interference goes at work. Because I mean, just last week we had a high altitude frequency, and it was during a C2 class flare that just went out. And here we've got 25 airplanes I'm talking to at 35,000 feet or higher, and I can't talk to them anymore. And all I hear is on the frequency, and it was due to sunspots. And there was nothing else I could do to fix it except change to a protected frequency, which we use sometimes, but they're not for long-term use. So I don't know the answer. If anyone knows better, it would be Rich.
I don't know, that's why I'm asking you.
If you're asking me, I'm saying we're right about 3/4 up. Because if it gets any more active, I'm going to have to quit my day job. Sir.
Do you look in the white light very much?
I do.
Okay. The reason I was saying that, I know in H alpha is pretty active, but I don't see a lot of stuff in the white light.
True. True. Well, relatively, there's still a lot of stuff in white light. The sunspots have not covered the surface like we hope they will. Like I say, I don't know. I wish I could tell you. My guess, as an experienced solar observer, which I definitely am, is that we are about halfway to 3/4 up the way to the next maximum. But I don't know. The point of this slide is that it goes in cycles. Nobody knows what causes the cycles. There's some talk now that the rotating currents underneath in the radiative zone of the sun have an effect, and they cause that. They travel about 30 miles per hour, according to NASA. The SDO probe that I sent you around, it has a helioseismological probe on it that's going to determine those things, supposedly. Okay?
Question.
Sir?
I'm trying to keep up with you guys. Are you saying
it's bright and hot and looks cool?
Are you saying eventually the sun is going to explode or something?
Yes.
Oh.
Yes. Yes, the sun will explode.
That's it.
In a few weeks. In a few weeks. December 21st of 2012, you can visit.
Kiss off. We'll meet you for our last potluck. Right?
Yeah, the treatment. Sunspot formation, again, is an unknown occurrence. Many scientists think they know why. But it is related to magnetic fields, there's no doubt. Nobody knows all the details of it. Hopefully SDO, which is Solar Dynamic Observatory, will give us more answers. These loops right here are reflected in the plasma here and here, and they twist all over themselves. And this is a reverse polarity region of magnetic fields going from one place to the next, just like any other magnet works. And they take parts of the surface of the sun with them when they go up in these loops. And that's what we see in the telescopes as prominences. It's just hydrogen plasma that's attached to those magnetic fields. It's really quite fascinating if you've never looked through one of the scopes. I'll be glad to come out to your school or group and do an event for you. This is an image from the TRACE probe, greatly enhanced with computer graphics, that shows this bright area here is the solar flare, according to scientists. Okay, that's what the solar flare is. Everything coming out of it follows along magnetic field lines, and these are what we call the prominences. Okay, so if you're talking to the solar type scientists, they get all weird if you say solar flare. Spicules, other things on the surface. The variation here in size and temperature is drastic compared to anything we know on Earth, but on the sun it's pretty much even all the way around. That's a pretty cool picture if you ask me, and that is the sun from the Solar Heliospheric Observatory. And remember, the size of this red dot is about the size of the Earth. The Earth's a little bit larger than that, but you know, we've had it if one of this comes towards us. These ones on the side, they're going away from us. Remember, we're standing here, you know, because the SOHO is right there at the L1 point photographing the sun. So luckily, those are going perpendicular to us, they're not coming at us, but they do come off the surface as well towards us. Like this right here is a huge looping filament. What's the difference between a filament and a prominence? Nothing. Filaments are what the scientists call one of these when their background of the sun is behind it. When they're on the edge of the sun, they call them prominences for some reason. It's just the way it is. So here's a filament here, here's a filament. This is a flare, 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 flare. And these areas are generalized as active regions. And the term active region describes the flare and the sunspots associated with it, the prominences associated with it. So if you hear the term active region, it means all those things. Yes, sir? Don't be driving with those glasses on. So, we move on to your question. How's it all going to end? Well, according to science, our sun is not heavy enough to end very spectacularly with a supernova or a black hole or anything like that. Remember the chart at the beginning that showed our relative size? We're really, really small. So the sun's going to run out of hydrogen at some point. It's going to collapse because there's not enough gas pressure going out from the center to keep it spherical. It's going to collapse to a point. Remember, when it collapses, the heat goes up. It's going to try to get hot enough to burn the leftover helium, but it's not going to be able to get hot enough because the amount of matter is not enough to generate that much heat. So it's going to turn into a white dwarf and leave a planetary nebula behind. Now, I don't know if everybody knows what a planetary nebula is, but it's, you know, funny it's called a planetary nebula because it destroys all the planets around it. But that's what a small star does when it collapses into a white dwarf. It leaves behind a lot of its remnants. Sir?
So what's going to happen is the outer shell, within, what is it, a few minutes, just collapses in and then bounces back out.
Right.
That's what a nova is.
Right. Well,
Not a supernova, because it's not big enough, but
yeah, a nova and a supernova both supposedly expel the outer layers first.
right.
The planetary nebula collapses and then a small amount. Supposedly, really, it's you know, who cares? I mean, it's just terms we use to describe it. It's all the same process.
So it looked like M51
M51.
in Vega, I mean in Lyra.
Snowball.
You mean
You mean the ring nebula?
Yeah, 57.
If you've ever seen a ring nebula in your telescope, which I have, and I'll be glad to show anybody that wants to see it, that's a planetary nebula. It's the leftover. When they saw them first, they looked like planets, I guess, or something. Or maybe they looked like planets orbiting around the sun, but there's nothing planetary about that nebula, believe me. That's the leftover remnants of an exploded star.
Question.
Sir?
The previous picture that you showed with the solar flares or prominence that's shooting out,
Mhm.
you said that it's shooting sideways from the, if it shot straight towards, or are we close enough that it would have an effect?
Absolutely.
It would.
During the solar maximum, these prominences have a drastic effect. It's funny because the kids I talked to at school, most of them were born during this current solar cycle, and they were born at solar minimum. And a lot of the technology that we've had developed here, like the Wii or the Nintendo or whatever game they're playing, I don't hate to say whatever the kids are playing these days, but I guess I'm old enough to say that. They're all internet connected, you got cell phones, all that stuff's going to be gone, I mean, for months on end if a large solar prominence strikes the Earth's magnetic field. So, sir?
I think in the 1800s, they had one in all the telegraph wires.
Right.
Yeah, fried, they just fried, so.
Right. And there was a picture of one in 1945 that was, just enormous. But, the likelihood of everything that's satellite-based being, what would you say, disactivated or deactivated for several months on end is fairly high during the next solar maximum. Yes, ma'am?
Didn't they have one in the 80s?
There was a power outage right in Canada.
In Canada and,
Yeah.
Yeah, and that was caused by a relatively small, storm that struck the
Well,
Earth's
actually,
magnetic
it
field.
used to be, there was a aurora you can see here.
A what?
The aurora borealis.
Yeah, the aurora.
It's actually visible all the way down to the Caribbean.
That's a good question, though. When those prominences come out, they strike our protective magnetic field. They usually get deflected away from the Earth, but if they're strong enough, it's going to deflect over to the other side of the Earth and snap back down, cause the auroras, cause all kind of satellites to be deactivated, and cause a bunch of havoc on Earth. So I find it fairly likely that in the next 5 years, something satellite-based will be knocked out and cause all of us a lot of grief. That's just my guess.
Keep the landline.
Yeah, keep your landline.
yeah, you better.
This kind of goes back to the last question about Kim had about what happens